How do projectors work? That's a great question. Before I say anything more, I'm curious, how do you think about projectors work? Now would be a good time to discuss about it. Okay, are you ready? When you go to the movies, have you ever wondered how those larger-than-life images are produced on the screen? As you may know, the answer to that is projectors, but their utility doesn't stop at movie theaters. Projectors are also used in boardrooms, conferences, classrooms, and countless other places to improve the overall user experience. There have been many kinds of projectors over the years, but the ones we will be focusing on are LCD and DLP projectors. To understand an LCD projector, let's start from the point where the light beam originates. First, there is the production of an intense beam of white light. The beam of light is then reflected off a group of mirrors, which includes two dichroic mirrors. The dichroic mirrors have a special coating that only reflects light of one type of wavelength. The white light hits the mirrors, and each one reflects a beam of either red, blue, or green light. The beams of red, blue, and green pass through an LCD composed of thousands of tiny pixels. An LCD is a substance that exhibits some properties of a solid and some properties of a liquid. Tending more towards a liquid, the LCD can either block light or allow light to pass through when electricity is passed through it. In the projector, there are 3 LCD screens, which are responsible for projecting the same image or moving images on a grayscale. When the colored light passes through these 3 screens, they relay 3 versions of the same scene, one tinted red, one tinted green, and one tinted blue. To achieve the proper hue, the tinted images pass through a dichroic crystal, which leads to the birth of a million colors. DLP projectors were developed in the 1980s and are based on a microchip known as the Digital Micromirror Device, or DMD. A DMD is a chip containing close to 2 million tiny mirrors in a square grid. An electronic circuit is also present, which helps in deciding the orientation of each mirror. A bright source of light is then directed at the DMD, and the electronic circuit individually tilts each mirror back and forth. If a mirror is tilted towards the lamp, it shines the light towards the screen. This mirror is representative of 1 pixel. If a mirror is tilted away from the source of light, it cannot reflect the bright source of light, thus leaving that screen space empty or dark. Each mirror works individually, and the 2 million mirrors go on to build a high-resolution image. To add color to the images, the DLP uses an extra bit of technology that consists of a colored wheel placed in the path of the light reflected by the mirrors of the DMD. The wheel consists of red, blue, and green. The combination of these colors, when bounced onto the mirror and then merged, results in an endless variety of colors in high definition. Finally, a lens collects all those beams of light to produce the final image. With all this in mind, the next time you kick back with a bucket of popcorn at the theater, you'll better appreciate how that movie magic is created.